Assalamu alaikum, my dear student. I am Dr. Naurin Khan, lecturer of Biochemistry department. Today I will discuss about the fluid and electrolyte balance chapter. From this chapter I will start the new topic. The topic name is total body water and its distribution. Total body water distribution. Total body water distribution will be different among different kinds of people, such as in early fetal life and in case of children the total body water will be more than adult male and adult female. But if we think about the total body water distribution in an adult male, obviously it will be more than adult female. Main reason is adipose tissue. In case of adult female, adipose tissue is more, total fat content is more in female than male. So in case of adult female, total body water will be less than adult male. So in case of if we think of 70 kg adult male, then in case of 70 kg adult male, total body water is about 60% of body weight, which is 42 liter. How we find out this liter result? Normally if any calculating kg, it may be 70 kg, it may be 80 kg, it may be 100 kg adult male, but always total body water is fixed in case of adult male, that is 60%. If we think about the 60% means 60 divided by 100, which we will multiply that result with the body weight of an adult male. Then we will get the liter result, which is 42 liter. So in case of 70 kg adult male, which is ideal, we will find out the total body water distribution 60%, which is 42 liter. Now come to the point, distribution. Total body water will be 42 liter or 60% of the body weight, which in case of 70 kg adult male. Icf and Ecf. Icf means intracellular fluid, which is 28 liter or 40% of the body weight, and Ecf means extracellular fluid, which is 14 liter, 20% of the body weight. So intracellular fluid will be 2/3 of total body water and extracellular fluid will be 1/3 of total body water. Now come to the point, extracellular fluid will be distributed again, plasma and interstitial fluid. Another name of interstitial fluid is intercellular fluid. Plasma is 3 liter and interstitial fluid is 11 liter. So total is 14 liter. Then come to the point, interstitial fluid will further divided into transcellular fluid and lymph. Now come to the point, what is intracellular fluid? Intracellular means inside the cell the fluid remains, that is intracellular fluid. Inside the cell the fluid is intracellular fluid. Outside this cell the fluid is extracellular fluid. And if there are two cells, between the space of two cells, that is intercellular fluid or interstitial fluid. Now come to the point, transcellular fluid. What is transcellular fluid? Transcellular fluid is the part of extracellular fluid compartment, but it mainly produced from the transport activity or secretory activity of the cell. Now come to the point, transcellular fluid importance. The importance of transcellular fluid is it is rich in mucopolysaccharide and glycoprotein, which make the surface slippery to prevent the mechanical friction or injury of the tissue, and it will make the slippery movement of the between the joint cavity or between the any space. Such as transcellular fluid example is pleural fluid. Between the two pleura, the fluid which remain, that is the pleural fluid, pericardial fluid which remains in the pericardial space, synovial fluid which will remain in the joint space, intraocular fluid, aqueous humor, fluid in the lumen of the GI tract and fluid in the lumen of the nephron. These all are the example of the transcellular fluid. And another important transcellular fluid is cerebrospinal fluid, from where we collect the CSF for lumbar puncture or for spinal anesthesia. That fluid is cerebrospinal fluid, which is the important transcellular fluid. Now come to the point, we will discuss about the ionic composition of extracellular fluid and intracellular fluid. There are many electrolytes inside our body. In the extracellular fluid compartment, the main electrolyte is sodium ion, and chloride ion. Sodium is the cation and chloride is the main anion of extracellular fluid compartment. And in case of intracellular fluid compartment, main cation is potassium and main anion is phosphate protein, these substances. Now we will show you the range of electrolyte in ICF and ECF. In case of extracellular fluid compartment, main cations are sodium. The level is 135 to 145 milli equivalent per liter. In case of biochemistry department, every value will be within the range. Potassium ion, value is 3.5 to 5 milli equivalent per liter. Calcium ion, that is 2.4 milli equivalent per liter. Now come to the point, anions. Cations are positively charged particles and anions are negatively charged particles. So chloride ion, which is negatively charged, 98 to 107 milli equivalent per liter. Bicarbonate ion, also negatively charged ion, 22 to 28 milli equivalent per liter, and others are 10 milli equivalent per liter. So in case of ECF, main ions are sodium, potassium, calcium, anions are chloride, bicarbonate, others anions. In case of ICF, intracellular fluid compartment, main cation is potassium, which is 150 milli equivalent per liter, calcium and magnesium. In case of magnesium, it is 40 milli equivalent per liter. In case of calcium, it is in case of sodium it is 10 milli equivalent per liter. Now come to the point, anion. Anions are same, phosphate will be 140 milli equivalent per liter, protein will be 40 milli equivalent per liter, chloride and others are 10 milli equivalent per liter. So in case of ICF fluid compartment, main cation is potassium, which is more than the ECF potassium content, and in case of anion, where the chloride was more, but in case of here ICF, phosphate is more and protein is more. So this is the ionic composition of extracellular fluid compartment and intracellular fluid compartment. Now we will calculate or we will measure the extracellular fluid compartment, intracellular fluid compartment and total body water compartment. Normally by the indicator dye dilution technique, by this mechanism we calculate or measure the total body water compartments. For this purpose there is a rule. The main rule is V is equal to M by C. V is the volume of the compartment, M means amount of indicator which will be injected, and C means concentration of the indicator of that compartment. For this purpose, in case of total body water compartment measurement, we will use deuterium oxide, tritium oxide. In case of extracellular fluid compartment volume measurement, we will use inulin, mannitol, sucrose, etc. And in case of the ICF fluid compartment, we will find out the intracellular fluid compartment by subtraction from total body water minus extracellular fluid, then we will get the intracellular fluid compartment. And in case of plasma compartment measurement, we will use radioiodinated serum albumin, Evans blue, and in case of the interstitial fluid compartment measurement, we will subtract extracellular fluid compartment from plasma compartment, then we will find out the interstitial fluid compartment. So this is all about the total body water and its distribution, transcellular fluid, which is very important, which comes in the written as a short note, and ionic composition of extracellular fluid compartment and intracellular fluid compartment, and total body fluid compartment measurement, which is measured by the indicator dye dilution technique method. So, today's lecture up to now, in the next class we will go for details more, inshallah. Thank you all.